Welcome to the DIY Honda Garage channel. This presentation addresses Diagnostic Trouble Code DTC P0236, which indicates a turbocharger boost sensor circuit range performance problem, specifically for Honda CRV models from 2017 to 2022. The turbocharger boost sensor plays a pivotal role in monitoring the boost pressure from the turbocharger, enabling the Engine Control Module, ECM, or Powertrain Control Module, PCM, to optimize engine performance. When this sensor malfunctions, it can lead to significant performance issues, as the vehicle may struggle with acceleration and fuel efficiency. Understanding this DTC is crucial for ensuring the optimal functioning of the turbocharging system, which directly impacts vehicle power delivery. In this guide, we will navigate through a structured troubleshooting process that includes symptom identification, potential causes, and a step-by-step troubleshooting methodology to resolve the DTC P0236 quickly and effectively. The turbocharger boost sensor is crucial as it measures the intake manifold pressure produced by the turbocharger. This sensor is typically located on or near the intake manifold, making it relatively accessible for inspection. The sensor's function is to provide real-time feedback to the Powertrain Control Module, PCM, regarding the boost pressure, which in turn helps the PCM make informed adjustments to the fuel mixture and ignition timing. If the PCM receives inaccurate or no data from the boost sensor, it might result in improper engine performance, potentially triggering DTC P0236. A malfunctioning boost sensor can lead to increased emissions, decreased power, and other engine performance problems, highlighting the importance of its accurate functioning. There are several potential causes that can trigger DTC P0236. The first and most common is a faulty turbocharger boost sensor itself, which may not be providing accurate readings to the PCM. Additionally, wiring issues such as frayed or damaged wires can disrupt the signal being sent to the PCM, causing performance issues. Loose connections at the sensor or at the PCM can also lead to intermittent failure, which may trigger the Diagnostic Trouble Code. Each of these issues can lead to a scenario where the PCM cannot accurately determine the current boost pressure, resulting in DTC P0236. Identifying and addressing these causative factors is essential for resolving the code and ensuring the vehicle operates smoothly. The symptoms associated with DTC P0236 can manifest in several ways. A noticeable symptom is reduced engine performance, as the vehicle may struggle to accelerate due to incorrect boost pressure information. Drivers may also observe the check engine light, CEL, illuminated on the dashboard, which indicates there is a fault within the engine management system that requires attention. Increased fuel consumption is another potential symptom, as the engine may operate inefficiently without proper boost levels. It's crucial for vehicle owners to recognize these symptoms and investigate further, as ignoring them can lead to more severe engine issues down the line. The first step in troubleshooting DTC P0236 involves verifying the problem through a series of actions. Begin by turning the vehicle to the on mode, allowing the systems to initialize. Using the Honda Diagnostic System, HDS, clear any stored DTCs, including P0236. Once cleared, start the engine and allow it to warm up. Hold the engine speed at 3,000 RPM without load, ensuring that both the engine and the turbocharging system are operating as needed. This process should continue until the radiator fan engages, followed by letting the engine idle for at least 6 seconds. After these actions, check the HDS for any pending or confirmed DTCs. which helps determine if the issue persists or if it was an intermittent failure previously recorded. In the second troubleshooting step, focus on checking the turbocharger boost sensor's parameters using the HDS. Specifically, monitor the TC boost pressure reading and compare it with that of the barometric sensor. The expected difference should be no more than 26.7 kilopascal, or approximately 7.9 inch in Henry and 200 millimeters of Henry. If the values exceed this range, it's indicative of a malfunctioning turbocharger boost sensor, warranting its replacement. Conversely, if the values are within this acceptable range, you will progress to the next troubleshooting step. This part of the process is critical because it determines the operational integrity of the boost sensor, directly impacting engine performance. In this phase of troubleshooting, we further assess the turbocharger boost sensor's performance. Start by noting the TC boost pressure value displayed on the HDS. Next, start the engine and hold the engine speed at 3,000 RPM without load until the radiator fan activates. Following this, increase the engine speed to 4,500 RPM without load. During these operations, closely monitor the TC boost pressure parameter using the HDS. A significant change of 0.67 kilopascal or 0.2 inch NG and 5 millimeter NG or more indicates that the turbocharger boost sensor is functioning properly, and you should advance to the next diagnostic step. If no change is detected, however, it further confirms that the turbocharger boost sensor is faulty and should be replaced. The fourth step involves verifying the overall vehicle performance through a brief test drive. Drive the car for several minutes while monitoring various parameters like engine speed, vehicle speed, relative throttle position sensor readings, and calculated load value as recorded in the onboard snapshot parameters. It is essential to pay close attention to the OBD status for DTC P0236 using the HDS during the drive. If the HDS indicates a failure, it confirms the need to replace the turbocharger boost sensor. However, if the HDS indicates the status as passed, it may suggest that the previous error was an intermittent issue. Thus, the system appears fine at this time. Alternatively, if the HDS shows not completed, you will need to retest and observe the OBD status again, as this will help pinpoint any unresolved issues. After completing the necessary repairs based on the earlier diagnostic steps, it's crucial to conduct a final repair verification. Start by confirming the successful repairs made, ensuring everything is tightened and secured properly. Utilize the HDS to clear all DTCs, including the once problematic P0236. After clearing the codes, it's important to retest the vehicle to ensure that the issue has been resolved completely. Monitor for any illumination of the check engine light, as well as the vehicle's overall performance during this verification process. This final step is essential as it reassures that the turbocharger boost sensor is now functioning correctly and that the vehicle is operating within its designed parameters. Preventive maintenance plays a vital role in ensuring the longevity and reliable performance of the turbocharger boost sensor and overall system. It is important to conduct regular inspections of the boost sensor to identify any signs of wear, corrosion, or damage. Additionally, periodically checking the connections related to the turbocharger boost sensor can avert future intermittent failures, ensuring reliable data transmission to the powertrain control module (PCM). Furthermore, maintaining a clean intake system is crucial, as dirt and debris can affect sensor readings and overall engine performance. By incorporating these preventive measures, vehicle owners can reduce the risk of experiencing DTC P0236 again. ultimately enhancing their Honda CRV's operational efficiency. To summarize, DTC P0236 indicates a turbocharger boost sensor circuit range or performance problem, which can significantly affect the performance of the Honda CRV from 2017 to 2022. The turbocharger boost sensor is critical in providing the necessary data for the powertrain control module, PCM, and any malfunction can lead to performance degradation. Through following a systematic troubleshooting approach, vehicle owners can identify, address, and prevent this issue efficiently. By understanding the symptoms, possible causes, and executing the appropriate verification steps, one can ensure smooth operation and longevity of the turbocharged engine system. Ultimately, addressing DTC P0236 promptly and effectively can lead to a better driving experience and improved overall vehicle performance. Please like and subscribe to the channel. See you next time.